Two is linear and nonlinear expressions. LEQ is what are the properties of linear and nonlinear expressions? So the expressions that we're going to be talking about in math are definitely not the ones you see here on the right. All right, let's go ahead and find out about expressions. To go ahead and kickstart our lesson, I want you to go ahead and pause the video to go ahead and see if you can solve these symbolic statements. Write them in symbols. This would be a preview from lesson 1. All right, welcome back. So let's go ahead and annotate. And I'm going to go ahead and annotate each statement here. So we have 12 more than a number. So 12 more meaning plus. And then a number, we're going to have X represent a number. With that, putting it all together, we have X plus 12. The difference of a number and 45, difference meaning to subtract. A number again is going to, X is going to represent a number, and then we have 45. So a symbolic statement would be 45 minus X. Last one, 5 less than 2 times a number squared. We have 5 less than 2 times a number, which is going to be X, and then we're going to square that. Putting that all together, we have 2X squared minus 5. Okay, so a linear expression in X is an expression where each term is either a constant or a product of a constant and X. So for instance, we have the quantity of 57 minus X. So here's our constant, and then we also have X. So that would make that a linear expression. However, this expression, 2X squared plus 9X plus 5, is not linear. Why is this expression not linear? Okay, so looking at the expression, notice that your variable here, X, is raised to the second power. So this would actually be the key on why this expression is not linear. Okay, so the meaning for linear expressions would be that as long as your variable is raised to a power that's equal to 0 or 1, if it's raised to any other power, then it is not linear. So let's go ahead and look at a couple of examples. How many terms does the expression 7x plus 9 plus 6 plus 3x have? Well, here's 1, 2, 3, and 4. So it has 4 terms. We want to go ahead and combine like terms. So I'm going to go ahead and add my 7x and my 3x. That's going to give me 10x. And then plus, I have 9 plus 6, which would give me 15. So looking at my variable x, the exponent is actually raised to the first power, which is 1. So this one would be linear. Okay, the next one, 94 plus x plus 4x to the minus 6 minus 2. You want to know if this is linear or nonlinear. Well, you wouldn't even have to combine like terms. Just looking at it here, this variable is raised to the negative 6. That makes it nonlinear. Okay. And the very last one is the expression x to the first power plus 9x minus 4, a linear expression. Yes, this is linear. And it's linear because your x is raised to either 0 or 1, and this one happens to be to the first power. So anything higher than the first power, or if it's a negative power, it's going to make it nonlinear. Okay, so now we're going to go ahead and incorporate what we learned from lesson 1 and then determine if that statement is linear or nonlinear. So we'll go ahead and change this into symbols. We have a number decreased by 3 squared. So we're going to have x minus 3 squared. Okay, and now I'm going to focus on my variable, my x, to determine if it's linear or not, and this one is linear. Next one, the quotient of 2 and a number subtracted from 17. So I have 17 minus 2 over x, and we want to know if that's linear or nonlinear. Being that this is in the variables in the denominator, that's actually going to be -1. So this would be nonlinear. Okay. So even though this is to the first power in the denominator, but when we rewrite it, it's going to be 17 minus 2 to the x to the -1 power. That makes it nonlinear. Last one, the sum of 13 and twice the number. So we're going to add, we have 13 plus 2x. Looking at my variable, there's no exponent here higher than 1, so this is going to be linear. And I guess I shouldn't say higher than 1. The exponent has to either be 0 or 1, and this one happens to be 1. Okay, to wrap everything up, we have definitions for linear and nonlinear expressions. Remember, we're going to be looking at that variable and seeing what the exponent is to determine if it's linear or nonlinear. We know how to use the definitions to identify expressions as linear and nonlinear, and we can write expressions that are linear and nonlinear.